Hello everyone, welcome to YourPedia Education. Today we will discuss the previous year paper of Cochin Shipyard Limited, that means CSL. This paper comes in December 2001. Here we discuss for electrical branch. First of all, we understand the pattern of the paper. In this paper, three sections. In this paper, question divided in three sections. Section 1 contains English. Section 2 contains aptitude question and section 3 contains technical question. Technical question, that means electrical branch question. Total question of this paper is 60, out of which 20 question comes from section 1 and 2 and rest 40 question comes from technical subject, that means electrical. If we further divide the technical part, then in technical part subject involves is electrical machine, power system, network, control, electronics, measurement. From machine, total number of question is 16. From power system, 8. From network, number of question is 4. From control system, number of question is 2. And from electronics, number of question is 5. And from the measurement, number of question is 5. So this is the sub part of the technical, in which machine contains 16, power system 8, network 4, control system 2, electronics 5 and measurement 5. Now we understand the level of this paper. According to my analysis, paper level is not much difficult, but we cannot say the paper level is too easy, because here numerical question is not so difficult, it's too much easy. By using formula you can get the answer, but theoretical question has some depth. To solve this question you must have depth in the subject knowledge, then you can solve this question. Now, if you are preparing for this exam, YourPedia Education launches dedicated module for this exam. You can join this module and you can enhance your preparation. Now, let's see question. First question is, in an energy meter, the steady speed of a DC of disk can be achieved when? In energy meter, to achieve a steady speed, that means constant speed of the rotating disk, option is braking torque is 0, second braking torque is more than operating torque, third operating torque is equal to or less than half the braking torque, and fourth operating torque is equal to braking torque. To get a steady state speed of energy meter, braking torque and operating torque, that means deflecting torque and braking torque, must be same. When this torque is same, in this case rotating disk operate at constant speed or steady speed. So the correct answer for this question is option D. Next, Next question is, which of the following connection is best suited for 3-phase 4-wire service? For 3-phase 4-wire service, best suited connection is delta star connection. Delta star connection. For 4-wire system, secondary must have neutral. That's why they provide a stable voltage. So secondary must be a star connection and primary must be delta connection. This delta connection suppress the harmonics. Suppress the harmonic. So for 3-phase 4-wire system, to eliminate the harmonics, we use delta connection in primary, and to provide a stable voltage on secondary side, we use a star connection because this connection has neutral point, and to provide a stable voltage to the load, we need a star connection. So for 3-phase 4-wire system, we use most best suited connection for this is delta star. So the correct answer for this is option C. Next is the most desirable factors contributing low cost electrical power generation. Low cost electrical power generation are, for low cost electrical power generation, load factor and diversity factor must have high value. Load factor and diversity factor must have high value. We know load factor is equal to average load upon maximum demand. Value of load factor lies between 0 to 1. To reduce the cost of power generation, value of load factor is high. Value of load factor is high. When load factor is high, in this case, utilization of electrical energy by load is most efficiently. So, to get the cost of the electrical power generation low, load power factor must be high. Now, we understand diversity factor. Diversity factor is what? Diversity factor is sum of individual maximum demand of the substation. Diversity factor is sum of individual maximum demand of substation to the maximum demand of whole system. To get the cost of power generation low, this occurs when value of diversity factor is high. Value of diversity factor is high, and value of diversity factor is always more than 1. When diversity factor is high, in this case, overall efficiency of system is high, and also load utilizes electrical energy in best suited way or best efficiently. So for this, correct answer is high load factor and high diversity factor. So correct option for this question is option C. Next question is, which among the following factors determine the time response of indicating type instrument? Time response of indicating type instrument depends on which factors? Here option A is deflecting system. We know deflecting system provide deflecting torque, for which pointer deflects from reference to the quantity which is measured, and the deflection depends upon the value of the quantity. So this provides deflection of the pointer. Next, controlling torque. Controlling torque controls the pointer at that point where we indicate the value of measurement at the measurement where there we provide measurement. In that place, deflecting torque is equal to controlling torque. So here controlling torque provides the controlling torque provides torque which is opposite to the deflecting torque and at the point where measurement shows deflecting torque and controlling torque is equal. Now, jewel bearing. Jewel bearing is used to provide support to the spindle or rotating mechanism. Next, damping system. When deflecting torque is equal to controlling torque, in that place pointer stops, but pointer has some oscillation. To damp out the oscillation of the pointer, we use damping mechanism. When we apply the damping mechanism, then the oscillation of the pointer stops and then we measure the value of quantity. So time response of indicating instrument depends on damping system. Time at which oscillation of the pointer stops, then we measure the value of quantity. So the correct answer for this question is damping system. Time response of indicating system depends on damping system. So the correct answer for this question is option D. Next question is, a 100:5 transformer is used in conjunction with 5 ampere ammeter. If the latter reads 3.5 ampere, find the line current. Here this is current transformer and their ratio of current is IP upon IS, that means primary current upon secondary current is 100:5, that means 100 upon 5. Now question is, this transformer is connected in conjunction with 5 ampere ammeter. 5 ampere ammeter. If the latter reads, that means ammeter reads the current in secondary side and their value is equal to 3.5 ampere. Current read on secondary side is 3.5 ampere. Then what is the value of line current? That means primary current. What is the value of line current? That means primary current. Here we know the ratio of IP and IS is 100 upon 5. By using this ratio, if we put the value of IS, we get here IP is what? IP is equal to 100 upon 5 into IS and their value is 3.5. If we simplify this, we get 100 divided 5, 20 into 3.5, and if we multiply this, their value is equal to 70 ampere. 70 ampere. So CT transformer which is connected in conjunction with 5 ampere ammeter, current indicate on primary side is equal to 70 ampere. So the correct answer for this is option B. Option B. Next question is, which of the following instrument is not desirable for measurement of AC value? Which instrument is not desirable for the measurement of AC value? First is moving iron repulsion type instrument. Second, moving iron attraction type instrument. We know moving iron instrument either repulsion type or attraction type, this instrument is capable to measure both AC and DC. AC and DC. Next, dynamometer type instrument also capable to measure both AC and DC. Permanent magnet moving coil type PMMC instrument only measures DC value. Here question is, which instrument is not capable to measure AC? So the correct option is D, PMMC type, that means permanent magnet moving coil type instrument only measures DC value, not AC value. Next question is the superposition theorem is used when the circuit contains. Superposition theorem applied in that circuit which has linear, active and bilateral network. When the circuit contains more than one source, then we take one source at a time active and other source is deactivated. And where we have find the value of response, we take one sources active one by one and the response obtained to that element or that branches is, lastly we add by taking, when we take one sources active, then the response obtained across any branches where we need to find the response is obtained, and finally by taking all the source one by one active, we get the output and finally we add. So superposition theorem is used when the circuit contains more than one source. Here option A is single source. No. Second, number of voltage source. Superposition theorem contains number of sources, more than one sources. So the correct answer for this is option B. Next question is, which of the following is not applicable to electronic oscillator? Electronic oscillator is a static device. Electronic oscillator is a static device. A static device which one minute. Question is, which of the following is not applicable to electronic oscillator? Electronic oscillator is a static device which converts DC power to AC signal. DC power to AC signal. Electronic oscillator has higher efficiency. High efficiency. Here question is, which of the following is not applicable to electronic oscillator? Electronic oscillator has characteristics of, as there is a static device but some wear and tear arises. So electronic oscillator has characteristics of little wear and tear. Their efficiency is high, not low. So which of the following is not applicable to electronic oscillator? Low efficiency is not applicable to electronic oscillator because electronic oscillator has high value of efficiency. So correct option for this is option B. Next, electronic oscillator has capability to provide good frequency stability. Also, in electronic oscillator, we have easily change the frequency of oscillation. We can easily change the frequency of oscillation. So option A, C, D all are the properties of electronic oscillator, and electronic oscillator efficiency have higher value. So option B is here correct, because electronic oscillator not applicable of low efficiency. Next question. Next question is, in an AC generator, increase the number of turns of the coil. We know in AC generator or synchronous generator, EMF generated EG is equal to 4.44 kc kd F phi t, where Kc is coil span factor, Kd is distribution factor, F frequency, and phi flux, and T number of turns. Here question is, in AC generator increase the number of turn. In AC generator, if we increase the number of turn, then what happens? As here Kc, Kd, F and phi, for that for not any mention, so here we take all this value as a fixed. Here only we change the number of turns, so here we write generated EMF is directly proportional to T. If we increase the number of turns, then in this case generated EMF increases. Generated EMF increases. So the correct answer for this question is option A. When we increase the number of turns, in this case induced EMF or generated EMF is increases. Next question is, class B insulation material can withstand a maximum temperature rise of dash degrees Celsius. Classification of insulation material based on temperature has mostly insulation material has classified on the basis of temperature, and there are some important classification is class A, class A, class B, class B, class F, and class H. Class H. Class A insulation material have capability to withstand up to 105 degrees Celsius. Up to 105 degrees Celsius safely. Above this temperature, may their insulation break. Class B insulation material have capability to withstand up to 130 degrees Celsius. Class F insulation type material has capability to withstand up to 155 degrees Celsius. And class H insulation type material has capability to withstand up to 180 degree Celsius. 180 degree Celsius. If the insulation material is class H type, then this material has capability to withstand up to 180 degrees Celsius. If we further increase the temperature above 180 degrees Celsius, then in this case it may their insulation break. So here question is, class B insulation material can withstand maximum temperature of what? Up to 130 degrees Celsius. That means correct option is option A. Next question is, a DC source generating 1000 volt. A DC source generating 1000 volt. 1000 volt has an internal resistance of 100 ohm. Find the load current if the load resistance is 900. This is DC source which generates 1000 volt, and this source have internal resistance of 100 ohm. 100 ohm. Now this source is connected to load resistance 900. Question is, find the load current, find current flowing through this load. Here we know I is equal to what? V by R or V by Z. Here this is DC circuit, so we write I equal to V by R. V is the voltage, and voltage of this circuit is 1000, and total resistance, internal resistance and load resistance of this circuit, total resistance of this circuit is what? 100 plus 900. So total current is 1 ampere, and here we know this is series circuit, and in series current is same. So value of current flowing through the load or value of current flowing through the battery is same, and their value is what? 1 ampere. Here question is, find the load current. So the load current is equal to 1 ampere. So the correct answer for this question is option A. Next question is, the main advantage for use of distributed winding in slots of synchronous generator is. If we use distributed winding in synchronous generator, first advantage is harmonics of generated EMF minimized due to this. First, harmonics of generated EMF minimized. Harmonics of generated EMF minimized. Due to this, generated voltage becomes more sinusoidal. Generated voltage becomes more sinusoidal. Second, if harmonics reduced harmonics frequency, eliminated, in this case iron losses reduced. And when iron losses reduce, then efficiency improve. Next, if you provide distributed winding in slots, then in this case machine operates more balanced. So here question is, the main advantage for the use of distributed winding in slot of synchronous generator is, first, reduction in size of machine, no. Reduction in harmonics of generated EMF. When we use distributed winding, then in this case harmonics of generated EMF reduce, so their EMF becomes more sinusoidal. So the correct answer for this question is option B. Next question is, which among the following statements are true regarding power transmission capacity? Which statement is true regarding power transmission capacity of high voltage AC transmission? Power transmission capacity of high voltage AC transmission. Here we know power transmission capacity of transmission line is Vs Vr upon XL sin delta, where Vs is sending end voltage, Vr receiving end voltage, and XL reactance of the transmission line. Here we neglected the resistance of the transmission line. This power transmission is obtained when resistance of the transmission line neglected. resistance of the transmission line neglected. Here question is, which among the following statements true regarding power transmission capacity of high voltage AC transmission? If the voltage transmission is high, then which option is correct? Here, if losses in the transmission line is very small, then in this case Vs is equal to Vr, and here we take their value as V. Also, if the power transmission to the transmission line is maximum, in this case sin delta is 1. Sin delta is 1. So, power P is equal to V square upon XL. Now, if the voltage transmission in transmission line is high, in this case power transmission is also high. Power transmission is also high. But when engineer try to design the high voltage transmission line, then they also care about the reactance of the transmission line, and their aim is to reduce their reactances. So, if the voltage level is high, then in this case power transmission is high, and also the designer of the transmission line also take care to reduce the transmission line reactance. So, if the voltage of the transmission line is high, then in this case power transmission is high, but the reactance of the transmission line is low. Reactance of the transmission line is low. Engineers always kept in mind that when we design high voltage transmission line, then must reduce the reactance of the transmission line. So, the correct answer for this question is increase transmission voltage and decrease line reactance. Increase transmission voltage and decrease line reactance increase the power transmission capacity. Here, increased voltage transmission and decrease line reactance and increase power transmission capacity. So the correct answer for this question is option A. Option A. Option A. Next question is, a semiconductor that decreases in resistance with an increase in temperature is known as. Question is, a semiconductor material having resistance decreases as the temperature increases. And here this properties follows thermistor, because thermistor is a semiconductor device. When the temperature of the thermistor increases, in this case resistance of the material decreases. Resistance or resistivity of the material decreases. So the correct option for this is thermistor. Other devices resistor has, and we also here write down the, if here temperature coefficient of the semiconductor material is negative. Temperature coefficient for this material is negative. Temperature coefficient is negative. What does means? Negative means if we increase the temperature of the material, then in this case resistance of the material starts decreasing. Resistor has mostly positive temperature coefficient. Resistor has positive temperature coefficient, and positive temperature coefficient means if we increase the temperature, if we their register have positive temperature coefficient. Positive temperature coefficient. Positive temperature coefficient. That means if we increase the temperature, their resistance also increases. Diode. Diode is an electronic device which has two terminals and it behaves as a switch. It behaves as a switch. Next, thermopile. Thermopile is a Thermopile is an electronic device that converts thermal energy into electrical energy. Thermopile is an electronic device which converts thermal energy into electrical energy. Electrical energy. So here question is semiconductor that decreases in resistance with increase in temperature. This characteristics followed by the thermistor. So the correct answer for this question is option B. Next question is damper winding are used in alternators. Damper winding used in synchronous machine. In synchronous generator or alternator, damper winding used to avoid momentary speed fluctuation called hunting. In damper winding used in synchronous generator to avoid momentary speed fluctuation or hunting. What is hunting? Sudden application or removal of load creates a speed fluctuation of the machine. To avoid this, we use damper winding. Damper winding used in synchronous motor to provide a starting torque, because synchronous motor is not a self-starting motor. To start this, we use damper winding which provides the starting torque. In synchronous motor, damper winding is used to provide a starting torque. So here damper winding used in synchronous generator to prevent hunting. Hunting is what? Prevent hunting. Hunting is what? Hunting means sudden application and removal of the load. A speed of the rotor or a speed of the machine fluctuates. To avoid this fluctuation, we use damper winding in synchronous generator. We use synchronous generator. Synchronous generator. So damper winding are used in alternator to prevent hunting. Next question is an induction motor fed from inverter. Induction motor is fed from inverter. Induction motor is fed from inverter, changes from motoring mode to generating mode. When we feed, that means power supply to the induction motor by inverter, induction motor operating mode changes, and the operating mode changes from motoring mode to regenerative braking mode. Motoring mode to regenerative braking mode. Regenerative braking mode. Regenerative braking mode. This happens when this happens when slip of the induction motor becomes negative. Slip of the induction motor becomes negative. Here what I say, when we provide the input to the induction motor by using inverter, induction motor starts operating from motoring mode to regenerative braking mode. This happens when slip of induction motor becomes negative. And when in the speed of induction motor becomes negative, we know slip S is equal to Ns minus Nr upon Ns. To get the slip negative, this happens when rotor speed is greater than synchronous speed. Rotor speed is greater than synchronous speed. Rotor speed is greater than synchronous speed. Now, to get the rotor speed greater than synchronous speed, here we change the frequency of inverter, because rotating magnetic field speed or synchronous speed of rotating magnetic field of induction motor depends on supply frequency. Here what I say, to get rotor speed greater than synchronous speed, here we change the frequency of inverter. If we decrease, then in this case we know synchronous speed is what? Ns equal to 120 F by P. If we decrease the supply frequency of the induction motor, then in this case synchronous speed of the rotating magnetic field decrease. And when this decrease, in this case rotor speed is greater. Rotor speed becomes greater, and when the rotor speed becomes greater, machine operate from motoring mode to regenerating mode. So here question is, an induction motor fed from inverter changes from motoring mode to regenerating mode when the frequency of inverter, that means frequency of supply to the induction motor reduce. So the correct answer for this is inverter frequency is decreased. When we decrease the inverter frequency, then in this case rotating magnetic field of the induction motor is reduced, and when their value reduce, then rotor speed becomes greater than synchronous speed, and in this case slip becomes negative. So the correct answer for this is option C. Option C. Next question is, class A insulation can withstand maximum temperature of. We discussed in previous question classification of insulation material based on temperature. According to temperature, we mainly classify in class A, class B, class F and class H. Class A has maximum temperature which withstand mean safely is 105 degree. 105 degree. So the correct answer for this is option A. Next question is, to two identical generators A and B. Two identical generators A and generator B have 6 pole each. Number of pole in both generator A and B is 6. Generator A has wave wound armature. Generator A has wave wound armature. Wave wound means number of parallel path in generator A is equal to 2. A equal to 2. While generator B has lap wound. In generator B, winding is lap connected, and in lap connection we know number of parallel path is equal to number of pole. Number of pole. The ratio of induced EMF in generator A. Question is, what is the induced EMF in generator A to the generator B? Generator B. We need to find the ratio of induced EMF. We know generated EMF is equal to 5 PNZ upon 60 into A. 60 into A. Where phi is the flux, P is the number of pole, N is the speed of rotation, Z number of armature conductor, and A number of parallel path. Here only mention about pole and number of parallel path. That means other value is fixed or constant. So if other value is fixed, then in this case we write E directly proportional to P by A. Also in generator A and B, number of pole is same, so this is also fixed. So this can we write as generated EMF inversely proportional to A. A is what? Number of parallel paths. Now take two cases of generator A and generator B. Generator A upon generator B. Generator B. Generator B. Here A is number of parallel path. A is number of parallel path, and this is in inverse relation. So here we write number of parallel path of generator B upon number of parallel path of generator A. A. Here number of parallel path in generator B is equal to what? A. Here generator B has wave lap connected, and in lap connection we know number of parallel path is equal to number of pole, and number of pole of generator B is what? 6. So number of parallel path is equal to 6. So number of parallel path of generator B is 6, and number of parallel path of generator A is what? 2. A is 2. Simplify this. If we simplify, we get 3 upon 1. That means generated EMF of generator A is to generator B is equal to what? 3:1. 3:1. So the correct answer for this question is option C. 3:1. 3:1. Next. Next question is, which of the following number specification refers to FET with one gate? Number specification of electronic device. Number specification of electronic device comes under NE, National Electron Device, NED National Electron Device Engineering Council. National Electron Device Engineering Council. According to this council, number according to this council, prefix of number specification represents number of junction or terminals minus 1. Number of junction or terminals minus 1. Here we say, according to National Electron Device Engineering Council, number specification of device is prefix of number specification represents number of junction or terminals minus 1. Here 1n represents diode. In diode, number of junction is 1. Number of junction is 1. So diode is represented by a specification 1n. Next, 2n is represented for BJT. BJT means bipolar junction transistor, and in bipolar junction transistor, two junction and three terminals. And 3n is represented for FET, field effect transistor, and 3n is used for those devices which have one gate. So here question is, here we say prefix of number specification. Here number specification prefix is what? 1, 2, 3. What indicates prefix of number in number specification represents number of junction or terminals minus 1. Here 1n represents one junction, and in diode we know number of terminals is 2. In BJT, bipolar junction transistor has 3 terminals: emitter, collector or base, and in BJT 2 junction, so it is represented by 2n. In FET, field effect transistor has 3 terminals: drain, source or gate. For one gate we use as 3n. So the correct answer for this is option B. Here question is, which of the following number specification refers to FET with one gate? FET with one gate is represented by 3n. Next question is, an induction motor is operated at a slip of 4%. That means 0.04 from a supply of 50 Hertz. Supply frequency is 50 Hertz. Then the frequency of rotor current is what? We know in induction motor, frequency of rotor current is equal to supply frequency into slip, or FR equal to S into F. Here in question, Slip is what? 0.04. And supply frequency is equal to 50. If we multiply this, there FR is what? FR is equal to 2 Hertz. That means rotor frequency of this induction motor, rotor frequency means EMF induced in rotor or current flows in rotor winding is what? FR, and their value is 2 Hertz. So the correct answer for this is option B. Here you can see numerical question is much easier, only formula putting getting, but theoretical question has some depth. So if we are preparing for this exam, this is best opportunity. YourPedia launches dedicated module for this exam. You must join this and take advantage to improve your speed of preparation. Next question is, time delayed or delayed action type fuses are designed to action type fuses are designed to option A, prevent ground in branch circuit, no. Prevent opens in motor circuit, no. Permit momentary overloads without melting. If we use extender fuse in case of motor, then when we provide supply to the motor, in this case initially current drawn from the source is high, because in motor case back EMF is not produced at the time of starting. So current drawn from the motor is high, and this current, high current, may damage the winding or may melt the extender fuse. To avoid this, we use delayed action type fuse. This type of fuse allow momentary maximum value or overload current initially. When the machine gets the back EMF or machine rotor synchronized with rotating magnetic field, in this case as overload or current drawn from the source is reduced and machine operates in normal condition. So initially when the machine is connected, if you understand by using synchronous machine, then in this case we simply say, if we provide synchronous motor supply, then in this case current drawn from the source is high, because rotor is not synchronized with rotating magnetic field. So current is high. If we use extender fuse, then this high current may melt the extender fuse. To avoid this, we use delayed action type fuse or delayed fuse, which permit momentary overloads without melting. But if the overload sustained for a long time, then time delayed switch also protect the instrument. This time delayed switch only allow overload for a few instant of time. So the correct answer for this is option C. Next question is, a repulsion type ammeter when used in AC circuit reads, we know, moving iron instrument works in two modes. One is attraction and other is repulsion. Here question is a repulsion type ammeter, that means moving a repulsion type moving iron ammeter when used on AC circuit reads moving iron instrument when used on AC circuit, it measures RMS value of current. It measures RMS value of current. RMS value of current. RMS value of current. So the correct answer for this is option B. Option B. Next question is the applied input AC power. The applied input AC power to a half wave rectifier is 100 watt. Applied input to AC. Applied input AC input is 100 watt. The DC output power obtained is 40. DC output power obtained is 40. What is the power efficiency of rectifier? We know efficiency of rectifier is what? Output power of DC. P DC upon PAC. Input power of AC gives efficiency. So multiply, if we take the rectifier efficiency in terms of percentage, multiply by 100. Here DC output power is what? 40 and input AC power is what? 100. Into 100, if we simplify, we get rectifier efficiency for this given input and output, this is equal to 40%. So the correct answer for this is option A. Here you can see numerical question of this paper is much easier, but theoretical question has some depth. Next question is a six pole 50 hertz 3-phase induction motor has full load speed of 950 rpm. At half load, its speed would be, question is, at half load, what is the speed of induction motor? Induction motor in RPM. We know synchronous speed ns is what? 120 F by P. 120, here F is frequency and the frequency is 50 and number of pole is 6. So synchronous speed is equal to 1000 rpm. 1000 rpm. That means when we provide the supply to the induction motor, rotating magnetic field speed is equal to 1000 rpm. 1000 rpm. Here question is, what is the value of rotor speed at half load? Also here mention rotor speed at full load. Now we first find the slip. Slip is what? S equal to ns minus nr upon ns. Here rotor speed is at full load, so we obtain slip at full load. ns is 1000 and nr is 950 upon ns minus nr upon ns, that means 1000. If we simplify 50 upon 1000, that means That means slip at full load is what? 0.05. Here we need to find the speed of induction motor at half full load. We know slip of induction motor is directly proportional to load. Slip of induction motor is directly proportional to load. If load becomes half, then slip also becomes half. So slip at half full load, half full load, half full load, full load is what? SFL is equal to S half full load is equal to slip at full load by 2, and the slip at full load by 2 is what? 0.05 upon 2. 0.05 upon 2. Now we need to find a speed at half full load. We know a speed of rotor with respect to synchronous speed or in relation with synchronous speed is what? Nr equal to ns into 1 minus s. Here we need to find rotor speed at half full load. Half full load, so ns is what? Ns is 1000. Ns is 1000. First of all, we take the value ns minus 1 minus slip at half full load. Half full load, here ns is 1000, 1 minus slip at half full load is 0.05 upon 2. If we simplify this, we get the value of the rotor speed at half full load, and their value comes to, if we simplify, their value comes to equal to 975 rpm. When you simplify, you get the value, and their value comes to 975 rpm. So the rotor speed at half full load of induction motor is 975. That means correct option for this is option C. Option C. Next question is, the electrolyte used in nickel cadmium battery. Electrolyte used in nickel cadmium battery is distilled water, and electrolyte used in nickel cadmium battery is a alkaline solution. Alkaline solution of potassium hydroxide, KOH, and distilled water. KOH and distilled water. Here question is, the electrolyte used in nickel cadmium battery is distilled water and KOH. KOH means potassium hydroxide. So the correct answer for this question is option B. Option B. Next question is, in an induction motor, rotor currents are circulated in the rotor by electromagnetic induction. Let's see, this is a stator, where a stator winding is placed. Here we only draw their construction only for understanding. This is not an actual diagram of the induction motor. This is a stator, and on a stator, this is a stator winding. When we provide three-phase supply to the stator winding, rotating magnetic field develop. Rotating magnetic field develop. And this field rotates at synchronous speed ns. This rotating magnetic field passes through the air gap and cuts the rotor conductor. As the rotor conductor is short circuited to the end ring, EMF induced and EMF then current, and due to the current flowing in the conductor, torque developed in the rotor and rotor starts rotating. So here linkage of flux to the armature conductor is happened due to the electromagnetic induction. So here question is, in an induction motor, rotor currents, this flux rotating magnetic field is passes through the air gap and cuts the armature, cuts the rotor conductor, and due to this EMF and EMF2 current develop in this winding or rotor. So current developed in the rotor is due to inductive reaction of rotating stator field. Inductive reaction of rotating stator field. Slip rings and brushes, no. Armature and brushes, no. Inductive reaction or electromagnetic induction. So the correct answer for this is option C. Next question is, a low voltage source is being used for testing armature coils. To test the armature coil, we use low voltage source. Next, a coil short circuit will be indicated by. To test the armature coil, we provide low voltage source. Here question is, a coil short circuited will be indicated by, if we measure the voltage across the coil and the coil is short circuited, in this case voltage measured is what? Then we know if the coil is short circuited, in this case voltage is 0. So voltage measured is 0 or very small, low or 0. While those coils which is not short circuited or which is healthy, their voltage is higher. So here question is, a low voltage source being used for testing armature coil, a coil short circuited will be indicated by 0 volt or low volt. 0 volt or low volt. So this is not low volt or 0 volt reading, while other coils have higher voltage. Those coils which have not short circuited or healthy, then voltage across that coil is high. So the correct answer for this is option B. Next question is, a parallel plate capacitor has capacitance of 10 microfarad if the linear dimension of the plate are double. Linear dimension of plate doubled, and the separation between them is also doubled. Linear dimension of the plate doubled and separation also double. The value of capacitor is what? Value of capacitor is what? Here question is, a parallel plate capacitor having value of capacitance is 10 microfarad. This is parallel plate capacitor. Now here we change there. Here we take the value of this parallel plate capacitor is C, old. Now we change the linear dimension of plate and there is a space between the plate. Here, what is the meaning of linear dimension? Linear dimension means width and length of the plate. Linear dimension means linear dimension means length and width of plate. Here question is linear dimension of plate doubled and separation also doubled. We know capacitor C is what? C is equal to epsilon A by D, where A is the area of plate and D is the separation between the plate. Where A is what? Area of plate. A is area of plate. A is area of plate. This is area of plate and the separation between the plate is D. Now we change their area and separation between the plate. Here what we change? Linear dimension double. That means we know area is what? Area is equal to product of length into width. If we double the linear dimension of the plate, that means L nu is twice the previous value, and W new is equal to twice the previous value, and also here separation between the plate is D. Here separation of the plate is also double, so D new is what? 2 times of separation. So capacitance is what? If we write C new, then C is what? C equal to epsilon. Epsilon is the permittivity and their value is fixed epsilon A new by D new. Area is what? Area A new. A new is equal to length new into width new, and their value is what? Length new is 2L and width new is 2D, so their value is 4LD. And here area in this case is what? Area here by mistake we write this as a D new. Here we take width is 2W, so this is 4LW. Now when the plate capacitance is 10 microfarad, in this case area is what? L into W, and distance between the plate is what? D. So put this value. If we put this value, epsilon A new is what? 4 LW upon D is what? D new is 2D. Now put this value, epsilon into 4 LW is equal to what? LW is equal to A, so upon 2D. Simplify this, we get 2 epsilon A by D, and epsilon A by D is what? Epsilon A by D is C old. Capacitance of old condition when we not changes their linear dimension and separation between the plate. So what is the value? 2. C old is what? Capacitance of old is what? 10 microfarad. So put this here. 2 into 10 is equal to 20 microfarad. That means if we double the linear dimension and also their separation between the plate, in this case capacitance becomes double and their value equal to 20 microfarad. So the correct answer for this question is option B. Next question is two register R1 and R2 give a combined resistance of 4.5 ohm when in series. Two resistors R1 and R2 are connected in series. We know when the resistance are connected in series, then equivalent resistance is what? Sum of the resistances. So R1 plus R2 is equal to 4.5. And 1 ohm when in parallel. When two resistors R1 and R2 are connected in parallel, their equivalent resistance is 1. We know when the two resistances are connected in parallel, then their equivalent resistance is what? R1 R2 upon R1 plus R2. R1 R2 upon R1 plus R2. R1 plus R2, and their value is 1. Here we know R1 plus R2 is what? 4.5. So if we simplify, R1 into R2 equal to 4.5. 4.5. To find out the individual resistances, we need to calculate their values. So to find out, here we know R1 plus R2, we find R1 minus R2. R1 minus R2, we know R1 minus R2 square, A minus B square is what? A plus B square, that means R1 plus R2 square minus 4 AB, that means R1 R2. Here R1 plus R2 is what? 4.5. 4.5 square minus 4, R1 R2 is what? 4.5. If we simplify this, we get the value of R1 minus R2, and their value comes to you simplified this. If you simplify, you get the value of R1 minus R2, and their value is equal to 1.5. Now here we get two simple equation, R1 plus R2 equal to 4.5 and R1 minus R2 equal to 1.5. Solve equation 1 and 2. Solve equation 1 and 2. Solving equation 1 and 2. If we solve this, we get their value. We get R1 is equal to 3 ohm, and R2 is equal to 1.5 ohm. 1.5 ohm. So the correct answer for this question is R1 3 and R2 1.5, or here R1 R2 is here 1.5 and 3. So the correct answer for this question is option C. Option C. Next question is, a transformer is working at its full load and the efficiency is also maximum. Transformer working at full load, and their efficiency is maximum. Maximum. Iron loss is equal to 1000 watt. Then copper loss at half full load will be, copper loss at half full load will be what? Here question given is transformer operates at maximum efficiency and full load. First of all, for maximum efficiency we know copper loss is equal to iron loss. Copper loss is equal to iron loss. That means WCU equal to WI. Wi. Now we also know at any load, at any load, at any load, copper loss at any load, WC at any load, at any load X, copper loss at any load X is equal to X square WCU FL. Here, for maximum efficiency, copper loss is equal to iron loss, and iron loss at maximum efficiency is 1000, so copper loss is 1000. But we want to know the value of copper loss at full load. Here, in this question also mentioned that here we find it when the efficiency of the transformer is maximum. In this case, copper loss is equal to iron loss, so copper loss is 1000 watt. Now, the maximum efficiency obtained at full load. At full load, that means at full load, full load X equal to 1. In this case, here we don't know what is the value of load to get the maximum efficiency, but in this question mentioned at full load maximum efficiency is occurs, so iron loss equal to copper loss, and due to this copper loss is 1000. Now at any load, we know copper loss at any load X is equal to X square WCUFL. This maximum efficiency occurs at full load, so if we put X equal to 1, here copper loss is what? 1000. 1 into WCUFL. So here we find it the value of copper loss at full load, and their value is what? 1000 watt. Now we need to find copper loss at half full load. Copper loss at half full load. We know the formula. Copper loss at half full load is what? Now copper loss at half full load, WCU at half full load, that means X equal to 1 by 2. Put this value. Here formula is what? Copper loss at any load is X square WCUFL. Here load is half, so 1 by 2 square, and copper loss at full load is what? 1000. Put this value here. If we simplify, we get the value of copper loss at half full load, and their value is equal to 250 watt. So the correct answer for this question is option A. Next question is, for a 100 kVA transformer, rating is equal to 100 kVA. For a 100 kVA transformer, the iron loss is equal to 1 kilowatt, and the full load copper loss WCUFL is equal to 2 kilowatt. The load at which transformer operates at maximum efficiency. Load at which transformer operates at maximum efficiency, that means kVA corresponding to maximum efficiency. We know load kVA corresponding to maximum efficiency is what? Full load kVA into under root iron loss upon full load copper loss. Load kVA corresponding to maximum efficiency is what? Full load kVA into under root iron loss upon copper loss. Here full load kVA is what? 100 into iron loss is 1 and copper loss full load is 2, 1 by 2. If we simplify, we get their value 70.7. That means 70.7 kVA. That means to get the maximum efficiency, load kVA is equal to 70.7. So the correct answer for this question is option A. Option A. Next question is, with negative feedback, the system stability and system gain respectively. This is the question of control system. We know in control system, if we provide negative feedback, in this case, system stability improve or increase. System stability increase and their system gain decrease. System gain decrease. So here the correct answer is, when we provide the negative feedback, system stability increase and system gain decrease. So the correct answer for this is option C. Next question is, the characteristic equation of the system is this. The system is here. In this question, characteristic equation of the control system is mentioned. Question is, check their system stability. Either the system is stable, unstable, critically stable or conditionally stable. To check the stability, we use Routh orbit criteria. Here, characteristic equation is equal to, here characteristic equation is sp power 4 plus sq plus 3s square plus 2s plus 5 equal to 0. Use this characteristic equation to form Routh table. Here, highest power of S is what? 4. So sp power 4 q s square, sp power 1 s 0. Now, to write down the Routh table, we first check the characteristic equation and we assure the characteristic equation must arrange in descending order. So here we check 4, 3, 2, 1 and s to the power 0. So here we take the value of s to the power 4 alternately. So coefficient of 4, s to the power 4, 1, 3 and 5. And coefficient of s to sp power q, take this value alternately, 1 and 2. Now complete the Routh table. 1 into 3 minus 1 into 2 divide 1. Now second, we solve for sp power 2 row and for second, here this value comes for second column. Now we use third column. Third column is 1 into 5 minus, here if not any value, then there is value of 0. So 1 into 0 upon divide 1. If we find their value, this is equal to what? 3 minus 2, that means 1, and this is what? Equal to 5. Now again use this to complete this row. 1, their value is what? 1 into 2 minus 1 into 5 upon 1. Here their value is what? Minus 3. And now here not any value given to this column, so here the value of this column is equal to 0. Further complete this minus 3 into 5, minus 3 into 5, minus, here if not any value given there, then the value is what? 0. 1 into 0, divide this value minus 3, so it comes to 5. Now to check the stability, nature of stability, we focus on first column of route table. First column of route table. We know if no any sign changes in the first column of route table, then the system is stable. Here we check. Sign of the first column is plus, 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 and here becomes minus. That means sign changes. And if sign changes, then this system becomes unstable. Since sign changes, and if sign changes, then the system becomes unstable. If sign not changes, then in this case system becomes stable. So the correct answer for this question is what? System is unstable. That means option D is correct. Next question is, while starting a synchronous motor, the ammeter measuring the current shows the maximum and then returns to the power to the proper value after synchronization. Returns to the proper value after synchronization. This indicates that we know in synchronous motor, when we provide the electrical input to the stator, in this case rotating magnetic field developed in stator. Now when we provide the rotating magnetic field, when we provide the supply to the stator winding, then rotating magnetic field developed in stator winding, that means armature winding. And when we provide excitation to the rotor winding, stationary field flux develops on the rotor. Stationary field flux develops on the rotor. Due to the interaction of rotating magnetic field and stationary magnetic field, net torque developed on the rotor becomes zero. During this, when we provide the DC supply on excitation, net torque of the rotor is 0. So total supply is given to the armature winding or stator winding. In this case, current is high. But when we provide external means to rotate the rotor near the synchronous speed, when we rotate the rotor near the synchronous speed, rotor field and stator field lock each other, and when this lock each other, then in this case rotor induced EMF develops, and this induced EMF opposes the supply voltage. Due to this, current reduces and the machine operated properly. So when we provide the supply to the synchronous motor, initially current in armature is high because rotor is not synchronized with the rotating magnetic field. But when the rotor synchronized to the rotating magnetic field, in this case rotor armature current or current in a stator winding reduces. Here question is, while starting a synchronous motor, the ammeter measuring current shows the maximum and then returns to proper value after synchronization. That means when the rotor field synchronized with stator field, current reduces. This indicates that motor has started properly. Initially, when rotor is not synchronized, current run from the source is high. When the rotor synchronized, current reduce. So this shows the motor has started properly. So the correct answer for this is option A. Next question is, the full torque electric brake on electric cargo winch functions to. Electric cargo winch is what? Electric cargo winch is a machine. Electric cargo winch is a machine who lift and lift or pull heavy loads. This machine has full torque electric brake. When we provide the electric supply to the electric cargo winch machine or device, in this case electromagnet of full torque electric brake magnetized, that means energized, and when energized, brake is released, and this machine is lifted the load or pull the heavy load. But if the current supplied or if the source connected to the electro cargo winch is stopped, that means if the current is zero, then in this case full torque electric brake electromagnet de-energized, and this brake grip the load at that position where they present. That means when current flowing to the electric cargo winch, this brake is releases, that means brake not connected to the load. But when the current reduced to zero in any means, then this brake applied to the load and it stay the load at where that they present. So correct answer for this is act as a backup brake, no. Automatically hold the load as soon as current to the machine is shut off. When the current to the machine is shut off, this full torque electric brake automatically shut off. This full torque electric brake automatically capture the load at that position where they present. So automatically hold the load as soon as the current of the machine is shut off. When the machine current is equal to zero, in this case full torque electric brake control the load or take a grip, hold the load. So the correct answer for this is option B. Next question is, auto transformer starters are sometimes used with polyphase induction motor. In polyphase induction motor, when we provide the supply, then current drawn from the source is 5 to 7 times of the full load torque, but full load current, but torque developed by this current is only 1.5 to 2.5 times. This excessive current may not damage to the induction motor, but the supply which the source which provides supply to the induction motor, if any other device is connected to that source due to the heavy current drawn by the induction motor, affect their performance. To avoid this, we use a starter in induction motor. Here mention is auto transformer starter is used to reduce the starting voltage of induction motor. So auto transformer increase voltage, no. Provide backup means of voltage regulation, no. Reduce voltage applied to the motor during starting. So the correct answer for this is option C. Next question is a resistance of 1 ohm connected directly across a voltage source with load line V plus I. A resistance of 1 ohm is connected to a voltage source with a load line V plus I equal to 100. Here 1 ohm resistance connected to the voltage source, and the current, when the source voltage connected to this resistance, current flows, and the relation between current and voltage for this circuit is given V plus I equal to 100, where V is the voltage output of the source, voltage output of the source, and I is the current through the resistance. I is the current through the resistance. Then the current through the resistance is what? If we find the value of current, I is equal to what? Voltage upon resistance, that means V by 1. That means here I equal to V. Here we need to find the current, put the value V is equal to I. So put this value. If we put V equal to I, here I plus I is what? Here I plus I is equal to 100. That means 2I equal to 100. Further, if we simplify, I is equal to 50. I is equal to 50. So current flowing to the resistance of 1 ohm, then current through the resistance is what? 50 ampere. So the correct answer for this is option A. Next question is, diameter of 10 SWG copper bare wire is. Here SWG is extender wire gauge, extender wire gauge, extender wire gauge, British measuring system. This is British measuring system, extender wire gauge, British measuring system, where SWG indicates diameter of wire, diameter of wire. Here there is no any direct formula to find out the value of diameter of different value of SWG. Here this value is fixed, and here we remember some standard value, some generally asked question in the exam and their values. Here given 10 SWG, if we write their value, then you remember this measuring system has no any relation to find out their value of diameter. It is completely based on their measured value or fixed value, which is decided by the British measuring system. So here we remember some renowned question which is asked in the exam, and this is you may remember this is 8 SWG means diameter of the wire is 4.064 mm. This is a renowned question. 10 SWG, that means 3.251 mm. 12 SWG means 2.642 mm, and 14 SWG means 2.032 mm. This is renowned SWG value. If you remember this, you can easily solve this question, because to find out the diameter of the wire using SWG system, you cannot use any formula. This is the fixed value of this. Here we see if value of SWG is smaller, a small SWG, a small swg, then in this case diameter of the wire is thick diameter. If SW is large SWG, in this case diameter of the wire is reduced, that means thinner diameter. So here question is 10 SWG means diameter of the wire of is equal to 3.251. So the correct answer for this is option D. Next question is, in an AC generator connected to main electrical bus, AC generator is connected to main electrical bus. The electric load and power factor vary by electric bus load is connected. This is generator, and this generator provide output power to the electric bus and load connected to the bus. Now question is, electric load and power factor vary. Their electric load and power factor varied. A corresponding change is reflected in the generator armature reaction. We know in synchronous machine, effect of armature reaction depends on power factor, and if we change the power factor, then in this case armature reaction effect arises. And if the armature reaction effect arises, then voltage of the terminal starts fluctuating. Voltage fluctuates. Electric power factor and load varies due to this voltage fluctuation starts at the terminal. Voltage fluctuations started. Question is, these changes in armature reaction are compensated. Here we say, if we vary the load and power factor, in this case armature reaction effect arises, and due to the armature reaction terminal voltage of the generator fluctuates. And to eliminate this or to compensate this, we use voltage regulator which regulates the voltage. We use to compensate this fluctuation, we use voltage regulator which regulate the voltage. So the correct answer for this question is option C. Next question is, the kVA of the generator is 80 kilowatt. That means P is equal to 80 kilowatt. P is active power and reactive power is what? 60 kVAR. Question is, kVA of the generator is what if P is 80 and Q is 60? We know S is what? S is the apparent power, that means volt ampere. S is equal to P plus JQ. And their magnitude is what? Under root P square plus Q square. Here P and Q is given. P is what? 80 square plus Q is what? 60 square. If you simplify this, you get their value, and this is equal to 100 kVA. So the kVA rating for this value is 100. So the correct answer for this is option C. Here we discuss all question or all technical question of this paper. I hope you understand. If you have any doubt, put your comment in comment section. Thank you for watching.